Hello and welcome back to another episode of Math with Sohn. Today we are going to be graphing some quadratic inequalities. Okay, so we have the three different forms of a parabola here. In standard form, I hope that we know that we need to do negative b over 2a to get our answer to the vertex. And in this case, it would be a negative 4, which is positive 4, over 2 times negative 1. And when we do that, we end up with a positive 2, a negative 2 for our x value. And then we plug in the negative 2, so that would be a negative, and then in parentheses the negative 2 squared minus 4 times negative 2, and then plus 7. If we do the math here, we end up with positive 8, and then this is negative 2 squared, which is 4, but then multiplied by negative 1 makes this negative 4 plus 8 plus 7. When we do the math for that, you end up with a positive 11, I believe. Let's see, negative 4 plus 7. Yeah, positive 11. Okay, so we're going to have to adjust the graph here. We're going to go to the left by 2, but then I'm going to go up and I'm going to pretend that this is negative 2, positive 11 right there. Okay, and that's okay. And then our y-intercept, we're going to pretend that this part right here is our y-intercept at 7. So when we graph this, it is going to be downward facing, and it would be a regular parabola. Everything that we've known and done is the same. The difference is that when we're graphing inequalities, you need to be careful that if it doesn't have an equal to symbol, it will be a dashed parabola or a dotted parabola. I like dashes. Okay? And then from here, we just need to shade. If it is less than, we need to shade below the vertex. So if I go directly below the vertex, I'm right here. This zone is going to be shaded in. Okay? So that is the zone that would be shaded in. And then we get to do the domain and range. The domain for these is still always going to be all real numbers. There might be a very extreme situation, but I don't think so. The range, you will have to be careful. The range is something that tricks a lot of people. So look at the direction the graph is going. The graph is going down, and the shading is going down. So they're working together. So in this case, everything is going down from the vertex, the shading and the graph. There are arrows here. All right? And if that is the case, then it is going to be y is less than the value of the vertex, which is 11 in this case. Okay? Now, notice how I did not put equal to 11. It's just less than 11 because it's hollow or not filled in. It's dashed at that vertex point. So it cannot equal the 11. You could also say from negative infinity up into 11 with parentheses around it. But I prefer the inequality because we're doing inequalities right now. All right? Next one. This one is in vertex form. So we get our vertex right away. It would be at negative 3, negative 2. Change sign, keep the sign. So left by 3, 1, 2, 3. Down by 2, 1, 2, dot. It is going to go down. If you want to plug in another point, you can, but the focus of this particular video is going to be shading and domain and range. So we're going to graph downward. We're graphing downward and filling it in with a solid line because this inequality has an equal to. All right? And because this means it faces down. All right? So equal to, solid parabola, but which way is it going to shade? It says greater than. Greater than is above the vertex. So if it's above the vertex, that would be this area right here, but it would also be everywhere outside the parabola. Okay? So that means that there's a whole lot of shading going on. All right? The domain, it still goes left and right forever, so it is still all real numbers, but the range, interestingly enough, is also all real numbers because the graph is going down and the shading is going up. If they ever conflict, you end up with everything. Your shading's going up, but your graph is going down. That accompanies all the numbers known to existence if that happens. All right? Last one for graphing, we got a factored form here, which means our two x-intercepts are 5 and negative 3. So we can plot those 2 points at 5 and negative 3. 1, 2, 3. And right by 5. 1, 2, 3, 4, 5. And this graph is going to be facing up. We do need to find the vertex because the vertex does involve domain and range, all right? So we have to find the vertex. We can't just be lazy and graph this facing upward because we don't know how far down this is going to go. So with that in mind, in order to find the vertex, you add the two x values together and divide by 2, thus finding the middle. And if we do that, you end up with 5 and -3. That's 2 divided by 2. You get an x value of the vertex of 1. If we plug in 1, you get 1 minus 5 times 1 plus 3. That ends up equaling -4 times +4, which is -16. Okay, so way down here at +1, -16 would be our vertex. And I have made a mistake. Uh-oh. This should be dashed. I made a mistake. This is why you should do things in pencil, not pen, but the pencil doesn't show up very well on the videos. I apologize. Maybe I can dash it a little bit right there. Okay. Which way should we shade? Well, the graph is going up, and the parabola, based off of this greater than inequality, by the way, in case you forgot, greater thans point to the right and less thans point to the left. So this is pointing to the right. That's why it's greater than. Greater than means we shade up, and up in this case is in between and above the vertex. All right. Next view, we are going to write the equation. Oh, I forgot to do domain and range. Domain, all real numbers. Range, which way is this graph going? It's going up. And the shading's going up, which means it is not conflicting information. They're going in the same direction. So this is going to be y is greater than -16. It can't equal 16 because it doesn't have the equal to symbol there. If it did, then it would. All right. Next one, we're writing the equation and stating the domain and range. Okay, so both of these are dashed, so they're both going to be just less thans or greater thans. And in this case, we have 2 points, but we also have the vertex. So I'm going to write it in, I don't know, which form do we want? We'll do factored form. We could do vertex form if we wanted to. Change the sign of both of the x-intercepts, but we have to solve for a. And when we solve for a, I'm just currently using an equal sign. Later on, we'll flip it to an inequality. We're going to plug in the other point that's provided. So this is going to be y is equal to a, 0 plus 2, and 0 minus 2. And what should we plug in for y? We should plug in the -4. So it should be -4 is equal to a, 0 plus 2, 0 minus 2. And -4 is equal to a, and then -4 when we multiply those again. And you find out that a is equal to 1, which is kind of sad because we probably would have just put a 1 there if we didn't do any of this math. But that's okay. So a is equal to 1. So now we have 1 with the x plus 2 and the x minus 2. What inequality symbol do I need? Well, the shading is going up. So the shading is going up, so it's a greater than symbol. And it is not equal to because it is not a filled in, but it is a dashed line. So this is going to be our equation. Our domain is boring. It's all real numbers. The range is going up from the -4. Oh, man. That's bad looking. -4. -4. All right. This number 2 problem is in vertex form because we have the vertex and then we have a random point. So this is going to be y is equal to, I'm going to do it here, y is equal to a, change the sign for the -1 to +1, don't forget the squared, -5, change keep. So if we change the sign, we get -1, we keep the sign, we get -5, we're looking good. We have to plug in the 0, -4, so that's going to be -4 for y, 0 for x. We're going to have to solve for a, so if we do that, we end up with -4 equals a times 1, because 1 squared is 1, and 0 plus 1 is 1, -5. You get an a value of 1 again, which is quite annoying. A is equal to 1a, so a is equal to 1. So now we can write our equation. It's going to be less than, because it's shading down, and it's not equal to, because it is dotted. And then we have an a value of 1, change the sign, keep the sign, get our answer. Okay? Domain and range, domain, all real numbers. range would be y is, actually, look at the graph. The graph is going up, and the shading is going down, so the range is all real numbers as well. Okay, solve each quadratic inequality. If you're solving, unfortunately, you typically have to graph, but you need to graph and solve. It's quite annoying indeed. So we do rough graphs, and we care about the x-intercept. So in this case, we are going to factor. We're just going to pretend that it's an equal sign, and we get x minus 5 and x plus 1. That multiplies to negative 5, but adds to negative 4. You get your two x values of 5 and negative 1. Okay, so we have an x-intercept at 5 and negative 1. Okay, if we graphed that, rough sketch, at 5 and negative 1, we're not doing anything crazy. We do know that this is a happy parabola. It should even be dotted, but I didn't care. It's a rough graph. Which way would I be shading? I would be shading up with this greater than symbol. So if I'm shading up, notice how I focused in on where is it in between. Is it in between the negative 1 and the 5, or is it outside of the negative 1 and 5? If it's an inequality, your answer is going to be dictated by where is the shading. So in this case, it is in between negative 1 and 5. That means that the x value is physically going to be in between the 5 and the negative 1. Or you could say negative 1 and 5 non-inclusive, okay? So both of those are acceptable versions of the answer. One of these may not be doing that, okay? One of these might be shading on the outside, and we have to be doing a little bit more writing. So here, again, it is in vertex form. That part doesn't matter. We still have to solve to get our x-intercept. So we're going to subtract 4. We get negative 4 less than or equal to negative x minus 2 squared. We should divide by a negative. When we divide by a negative, it's going to flip this inequality symbol. However, that's not going to be how you get your answer. So I'm just going to recommend writing 4, and then, yeah, you can flip your inequality symbol, but pretending it's an equal sign means that some crazy stuff's going to happen anyways. Square root both sides. Plus or minus 2 less than an x minus 2. When we add the 2 over, we get x equals 2 plus or minus 2, which means x is equal to 4 and 0. Okay? Again, a rough sketch. If we do a rough sketch where we have 4 and 0, and we know that this graph is sad because it is facing down, we could even plot our vertex here, then it would look something like this. Which way should we shade, though? It's greater than. We should shade above and outside. So that means that it's not in between the 0 and the 4. It is before the 0 and after the 4. It's where the shading occurs, which is before the 0 and after the 4. All right? So with that in mind, we have to say that x is smaller than 0, x is smaller than or equal to 0 because there's an equal to symbol here, and x is greater than or equal to 4. You could also say from negative infinity to 0, including the 0, and, united with intersection? I think it's union. And from the 4 to positive infinity there. Okay? Last one is hopefully factorable. Let's see what happens. We have negative 2. Everything divides by 2, so I'm going to do that. That's going to make this x squared minus 6x plus 18. Nope, plus 9. And that does factor. That ends up being x minus 3 and x minus 3 multiplying to 9 and adding to negative 6. So we got 0 greater than or equal to. Well, in this case, we only have one answer. That's kind of unique. So we have x-intercept is equal to 3. Okay. Wonder why that's the case. Well, if we found the vertex out for this problem, you would find out that the vertex is at 3 because it happens to be the only x-intercept and it is facing down. Okay, if that's the case, then the only place where it crosses the x-axis and therefore the only solution that you have is x is equal to 3. That's it. That's the only one. If we did it, and that's because this is also vertex form, x minus 3 and x minus 3 is y equals x minus 3 squared. It's just to the right by 3. Okay? So, one more application problem. I know this seemed like a longer video. Apologize. Didn't think it would be. If you want to fence in a rectangular space where the lengths need to be 5 more than the width, okay, and the total area enclosed needs to be at most 300 square feet. What are the possible lengths and the widths that are possible, okay? So we know that the length needs to be, the width is equal to the length plus 5. Nope, other way around. The length is equal to the width plus 5 because the length needs to be 5 more than the width, okay? We also hopefully know from geometry that area of a rectangle is length times width, all right? So if that is the case, our area this time is equal to length times, we're going to replace this width with, no, actually, I am sorry. It is going to be, we're going to replace this length. See how the length is equal to w plus 5? We're going to replace that length with a w plus 5. So w plus 5 times another w. Place that length. That means that the area, which is at most 300, would have to equal a w squared plus 5w. Set it equal to 0. We get 0 is equal to w squared plus 5w minus 300. And what multiplies to 300 but adds to 5? That is an excellent question. I need to find a calculator, maybe. Let's see. We got 300 divided by 1 is 300. 300 divided by 2, 150. 3, 100. 4 would be, I don't know. What is 300 divided by 4? I don't think it's 4. 5. It's maybe 10. 10 is 30. So we're getting closer. What is 300 divided by 15? I think 300 divided by 15 is 20. I believe it is. 20 times 15. Yeah. So that means that it is going to be w plus 20 and w minus 15. So that means that the widths that are possible are negative 20. That's not really possible. And the width that is possible would be 15. Okay? So that's the other width. Okay, so we're going to graph this still either way. We have negative 20 for a width. We have positive 15 for a width. And then we have to think about what should have been the inequality that we had here when we were doing it. So it was said at most 300 square feet. So that means that when we did the area had to be smaller than 300. So this is the area part when it was equal to 0. So it had to be at most. So this should be a less than pointing to that direction. All right. 0 has to be greater than that, or the 300 would have to be, the area would have to be at most 300 square feet. Let's just go through the math and see what happens. All right. Because that at most is throwing me off a little bit. We graph it. It's going to either be smaller than 15 and bigger than 0, or bigger than 15. So let's think about that. Can the width be 0? Can the width be 0? And the answer to that is no. Because if the width was 0, length times width would not equal 300. All right? I mean, technically it could, because we don't need to build a pen. But it could be anything bigger than 0. Okay? So the width is in between 0 and that 15. And once it hits 15, what would happen if it hits 15? Once the width hits 15, then the length would be 20 when the width is 15, because the length is 5 foot more. And if the length was 20 and the width was 15, what would be the enclosed area? 300. So the length is going to be from 20 to 5. Okay? And those would be the possible dimensions, but they would kind of be proportionally up with that. All right? That's going to be it for this one. Until next time, stay positive, my friends. And by the way, I would have probably recommend guessing and checking for some of these application problems, because guessing and checking is still a reputable method. See you then. Bye.